Okay. So easiest way to do this example is to draw the net for this and calculate the area of each of the faces and then add them together for the total surface area. So this front face, as Charles said, this is a trapezoid. If you look at your formula sheet, we are given the formula for area of trapezoid. So a plus b times height divided by 2. A plus b times height divided by 2. All right, that's the formula for trapezoid. Let's say you weren't given it. Yes, you could do what Sydney said earlier. Do the area of the triangle plus the area of the rectangle. You could do that as well. Okay. So what's the A and what's the B in this there? Oh, sorry. Let me put in these numbers. So this is 10, 4, and 8. Okay. What's A and what's B here in this trapezoid? Priyash? In this trapezoid, what's A and what's B?
A is 8, and then B is 4.
Alright, so A and B are the two sides of the trapezoid. So it's actually the 10 and the 4. Alright, and then the height of the trapezoid is the 8. You can think of it as like the looking at it sideways, like this. Alright, then you have your 2 base and the height. Okay. So 10 plus 4, 14 times 8 divided by 2, you get 56 centimeters square. Okay. So we took care of the front face. Okay. Now the top part. What shape is this top? Just the top. Yep. Rectangle. That's it. So I have the 10 by 4 rectangle. Okay. Area of that is just 40. Okay. What about this one? What shape is this? Sam? It's another rectangle. The small rectangle with dimension 4 and 3. So area is 12. Okay. What about the bottom? What's the dimension of that rectangle? 8 by 3. 8 and 3, so area is 24, because you're just doing length times width. And what about the back right here? 10 and 3 as well. Good. 10 by 3, which is 30. Okay. How many sides are in this figure? Yeah. Did I make a mistake? Which one? Oh, yes. Yeah, the top rectangle should be a 10 and 3. Thank you. And by 3. So that should have been 30. Thank you, Dallas. Okay. Take a look at the whole figure. How many sides, how many faces does this figure have? Charles? Say that again? Yeah, it's just a, yes. So even though you can't see on this side, it is a closed figure. Okay, so how many sides does this figure have? 6. So when I add up my area, my surface area, I should be adding up 6 numbers. So 56 for the front face, 56 for that back, because it's the same. The front and the back are the same. The top rectangle, the small side triangle, rectangle, the bottom rectangle, and the side tall rectangle. Okay, 1, 2, 3, 4, 5, 6, 6 faces. And when you add it all up, you should get 208 centimeters square. Okay. So when you're given a shape where it's hard to just use these given formulas, when it's hard to just use one of these given formulas, the other option you could do is just break it in parts. Okay, unfold it, draw the net. Okay, this one, example 2. Two round cakes have diameters 14 centimeters and 26 centimeters, and each are 5 centimeters tall. They are arranged as shown, so you're putting the small cake on top of the big cake, and you're covering it in frosting. What is the area of the frosting? Right, so those of you who've made a cake before or did some baking, we're just putting that sponge cake on top of each other, and then we're like spreading the icing all on top of it on the areas that we see. Okay, so what shapes is involved here, Sam? Cylinder, right. If you forget the name, you can always refer to your formula sheet. Cylinder. So let's calculate the surface area of the top cylinder. So area of the small cylinder, 2 pi r squared plus 2 pi r h. Okay, right. Surface area of a cylinder. That's the formula. Okay. This tells us the area of this whole small one. But Priyash, okay, which part do we not want? The bottom, right? The bottom of the cylinder, we're not putting icing on there. So what do I have to do to this formula? Charles?
Do from the formula that takes care of the surface of the circumference.
Right.
So which is both the square.
Okay. Not remove the square, but remove the 2. Okay, because the pi r square, the 2 pi r square is the top and bottom circle. Since we don't want the bottom, I'm gonna just take out the 2. Okay, so that means this is the top circle, and then this is the lateral side. Hey, pi 3.14 times radius. What's the radius of this circle? 7, right? Half of it. So 7 squared plus 2 times 3.14 times radius times height. Okay. When we calculate that, we should get 373.66 centimeters square. Okay. I'll write like AS for area of the small cylinder. And now the area of the big cylinder, the bottom. Area of the big cylinder on the bottom right here. So since it's a cylinder, I'm going to use the same formula, 2 pi r squared plus 2 pi rh. Okay. But again, what do we not want in this big cylinder? Yep, the bottom. So yeah, we don't do that again. What else do we not want? The bottom of the top circle. So we also have to subtract. Oops, sorry, let me use this. Subtract the pi r square of the small circle, right? Because this part right here, we don't want. Highlight it. We don't want the bottom circle, and we don't want the bottom of this small circle. That's why we have to subtract another circle. Okay. So pi 3.14, radius of the big circle, 13. Oh, that's an ugly 3. And then plus 2 times pi, radius of the big circle is 13, height of the big circle, why do I keep saying circle? Cylinder. Cylinder is 5, and then take away 3.14, times the radius of the small circle, small cylinder. So 7. Okay. And when we multiply, 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 and then add, subtract everything, you should get 785 centimeters squared. Okay. When you do this all in your calculator, you can just do it on the calculator and then give me the answer. You don't have to show every single calculation unless you think you're going to make a silly mistake. Then do the extra step. Okay, what's my final step? Sam? Add them together, right. You found the area of the small cylinder, you found the area of the big cylinder, so now their total, your surface area total, is just 373.66 plus 785. So you get the final icing surface area, 1,158.7 centimeters square. Okay. When you do these calculations, notice I didn't round in the middle of my calculation. I only rounded in my final answer. Okay, keep that in mind because otherwise you'll have rounding errors. Okay. Any question on this one? This one I would say is as hard as you'll see on the test. In the homework tonight, you'll do some like similar questions. You see that again, here's another 2 cylinders. Here's rectangular prism and triangular prism. So these type of questions is as hard as you'll see on the test. Example 3, I actually changed this example 3, so you can just actually cross that out. All right, new question. So if you guys can just write it down somewhere, the new question. A new example 3, because that one takes too long. I did it with my gifted class and it took too long. So I'd rather change the question to a different type. Okay, so if you can change question number 3 to this one instead. Okay, so a new example 3. Okay, as you guys said, I want the surface area of a cylinder because it's a Campbell soup can. So this is the formula for a surface area of cylinder. Seems nice and easy. I have the formula. I'm not taking out any sides. But what's wrong? Why can't I just go straight to this formula? We don't know what, sorry? We are given the radius, but we're not given the height, right? We don't know this. Right. So that's why, as Sam said, but we are given the volume to be 500. So let's use the volume formula. Pi r square h. That's the formula for volume of a cylinder. So the tricky part to this question is I know I'm looking for surface area, but I still have to use the volume formula. Okay, so volume 500, pi is 3.14, radius is 4, and I just don't know h. So now that I have every single number, I can actually solve for h. Okay. So I can figure out what this side is first. So 500 equals 3.14. Oops, I should turn on my calculator. 3.14 times 4 times 4. So I get 50.24 h. How do I solve for h now? Yep. Right, divide, because I'm multiplying here, so opposite is divide. divided by 50.24. So 500 divided by 50.24. I get 9.95. What's my unit here? Yep, centimeters, because it's a height. So not square, not cube, just 9.95 centimeters. Okay, now that I have H, I have R, I can now apply it in this formula. So 2 times 3.14 times the radius, which is 4, plus 2 times 3.14 times the radius times the height, which is 9.95, what we just found. Okay. On your calculator, you can do it all at once if you want. 2 times 3.14 times 4 times 4 plus 2 times 3.14 times 4 times 9.95. Oh, by the way, you can do this all on your calculator if you can see exactly what you type. Because when you type it out, your calculator will know to do a bed mass itself. But if your calculator doesn't show you what you type, like this type of calculator, then you would have to do this part first, write down the answer, this part, write down the answer, and then add it together. All right, so know your calculator. And you get 350. We'll round it to 350. What's my unit here? Yep, centimeter square, because it's surface area. So therefore, you need 350 centimeters square worth of aluminum to make this can. All right. You don't have to write me a therefore statement. You can save some time, but I need to see units. All right. Any questions? All right. So as I said, the trick with this one is I know I'm looking for surface area, but I can't jump right into the formula because I don't have all the info. And so that's why you have to use the volume. I guess your hint is that it tells you the volume. So that tells you that I should probably use the volume formula. Okay. So for your homework tonight, just page 20. Just this, page 20. This is actually in the old package. It was page 18, I think. It's the exact same thing, but I just put it in this one instead. Okay, I changed it to the order. So just page 20. All right.